Hello and welcome. Today we're going to set up a local language model. We want to have the embeddings local and also the model. Why would you want a local model? Well, because maybe some clients don't want their data to be sent to OpenAI, or maybe yourself want to query some of your documents without sending them to OpenAI. So we want to learn what the possibilities are and play around a little bit. This is basically going to be the example from the Llama index website themselves, and I'm going to point out some things, some changes, some errors you might get. Let's get started. Let's install a new environment first. The requirements we're going to need are going to be Llama index, of course, langchain sentence, transformers, and PyPF. Yes, I think that should be sufficient. Okay, so we want to work with the Hugginface LLMs. Let's go to the Llama website and look for the interface to import. Here we have the multiple LLM implementations. We're going to work with the Hugginface LLM. First thing to notice, sometimes you see LLM predictors and sometimes just LLMs. LLM predictors seem to be deprecated, outdated right now. So if you see them in some tutorials or anywhere else, you can replace them with the LLM class. Okay, let's get imports from index import. From Llama index import. Simple directory reader, list index service context, and also langchain embedding, and also set global service context. Then from Llama index prompts import simple input prompt. Then we're also going to need from langchain embeddings Hugginface and Hugginface embeddings. The embeddings have to be loaded from langchain, and then they're going to be wrapped with a Llama index wrapper function or class. Okay, we're going to use the stable LM tuned alpha 3b. Yeah, here are the parameters that are necessary: stop IDs, tokenizer, the model name, system prompt, and we can see here in the model card what we're actually going to need. So stop IDs, system prompt. Let's do this. So the large language model is going to be the Hugginface LLM. Context window, where is it defined? Okay, not here. Then we're going to look in the config file. So the hidden size 4096. This is going to be our context window. New tokens are generally 256. Generate keyboard arguments. What the temperature does, it basically sets the creativity level of the model. So I want to summarize a PDF file I have. I don't want the model to be very creative. I just want a summary of the contents from the book. So we are going to set it to something like 0.2. Okay, next we're going to need the system prompt. Let's define it up here. You can just copy it. That does everything the user wants. So the next thing we're going to need the actual prompt, which will be wrapped also. The query wrapper prompt is going to be the simple input prompt. Looks like this: user assistant. If there's something you don't understand or you don't know, you just go to Google and put Llama index simple input prompt, and it's kind of all over the place right now. Llama index gets updated every day. Yesterday the version was 7.3, the day before 7.2. So defining prompts, they have some default prompt templates. The single input prompt is basically just default prompts. From prompts point prompts. Yeah, it just is a normal prompt. The next thing, the tokenizer name and the model name, we're just going to take the ones provided here. The device map is going to be set to auto. For myself, this doesn't work. It tries to allocate it on CUDA. I set it to CPU. You have to play around a little bit. And the stopping IDs, yeah, they're defined here. Tokenizer, quarks, max length, just set it to the same. So next we're going to need the embedding model. Here's what I mean, that it's a little bit chaotic here. I don't directly see where the embeddings are. So again, let's go to Google, search for the embeddings, and there we get to the embeddings. Here they have it. If you want to work with custom embeddings, so embeddings that are not from OpenAI. As you can see here, you have to take the Hugging Face embeddings from langchain and then wrap it to the langchain embedding from Llama index. So as far as my knowledge goes right now, the embeddings that are for free from Hugging Face, the sentence transformers, all minim LM. So this one basically seems to be really good, and this here would be another one. And I've tried these here, they have worked pretty good. So next we need to define the service context. Here's the point where you often see the LLM predictor, and as I told you at the beginning, it's just use LLM, it doesn't make a difference. And the chunk size 4096. So here another tip. As of right now, even though we set the embeddings and also the models to Hugging Face, I get the error that I don't have an OpenAI key, so somehow the service context is still trying to pull from the embeddings from OpenAI. So you have to set the global service context to the service context here. So now it's going to take our Hugging Face embeddings and not the OpenAI embeddings anymore. Okay, I have a PDF file of a book about freelancing in the data directory. So we're going to take the simple directory reader. There are different indices that we can use. I'm going to make a separate video to explain them, but for a short explanation, the list indices are chunking up the document in different nodes. So a node is just a part of the document with a specific chunk size. If we're going to make a query, then the list index is going to take the whole document, so all nodes, to the model, which is then going to search in each node and combines the whole knowledge. This is pretty good for summarization tasks, but it's also computationally heavy because we are putting into it all the nodes, so have that in mind. Also another thing, if you're watching older tutorials, you're often going to see GPT list index, GPT vector store. They changed it now and it's just list index or just vector store. Okay, we need to load the documents with from documents. List index from documents. Now we need to define the query engine as query engine. Now query how to win a client and response results. Okay, let's run it. Maybe I forgot some requirements, and obviously it's going to take some while because it has to download the embeddings, the model weights. Okay. Every time a new error. This looks really strange. I'm going to restart the machine. I think I encountered something like this in the past and it could be solved with a restart. We'll see. The restart did nothing. Let's just remove this environment, create a new one, and let's see if this helps. We need to install Accelerate, but it works now. I don't know, sometimes some things are just broken. Okay, now it lost the checkpoints, finally. Okay, embeddings takes one positional arguments, but two are given. Okay, face embeddings. Model name, yeah, okay. Another error. So apparently for the simple input prompt, the parameter here should be query str, not query string. Now finally. Okay, there we have it. Took like 5 minutes. Research the business. Call to action. Yeah, sounds reasonable. I mean, the output is pretty good actually, but 5 minutes computation time. Good. I mean, I've done it on the CPU. Hello, it's me from the future. I just wanted to add the CUDA part. It's actually not that hard. We just have to load the model with the transformers library and have to put it in the evaluation mode. It deactivates unnecessary layers or paths or neurons, which are necessary for training, but have no function in the inference part. These get deactivated, so the model is a little bit smaller and can actually fit on my GPU, which is 8 GB. So the 3 billion parameter model should, with 16 float bit
it should take like 6 gigabytes plus the 1 gigabyte for the embedding model. In this case, my GPU is sufficient then. The execution time now is got approximately cut to half. I didn't make exact measures, but approximately. But you have to consider that with the list index here, every node, so from the document, which is a whole 80-page book, got parsed for the output. So it's still pretty good, I'd say. But we have to play around, try it with some other indices that should work faster. And that's it for the CUDA part. Also keep in mind, you saw me encounter a lot of errors here. In most tutorials you don't see those errors. This is just a part of it. It happens every time, specifically with Python, specifically in this machine learning, artificial intelligence area here, because the libraries are changing every day. So you'll encounter some errors, some changes. Don't get encouraged, just research, read the documentation, and if you really can't progress at some point, just set it aside, work on it next day, or you might get a burnout. So I hope you enjoyed watching. More tutorials are going to come. Thank you for watching. See you in another video.